Hello and welcome back to a new video here on the Ludwig Fusel channel. In today's video we're going to continue on with our exploration of the Boost C++ libraries with the algorithm library. So today we're going to talk about algorithms provided by Boost. Now this is, I think, going to be quite a fast video because, well, I'm not definitely going to take a look at all of these algorithms that are in here, because, well, most of them, they are more or less self-explanatory, so you basically know what's going on. Now what we're gonna in general do is we're gonna take a look at the kind of like the classes of algorithms, and maybe we're gonna go a bit over them so that you can kind of like see what the idea of the algorithms are. Now let's start with the searching algorithms. The searching algorithms are algorithms for full text search, so searching a string within a string basically. Now what I've already done is I've prepared a new project in my Visual Studio solution using Premake and my build system. Just created a folder and copied the build.lua and adapted it so that it has a different name. Alright, so what I'm now going to do is I'm now going to include that. So we're going to include Boost algorithm, and then we're gonna go for searching, and I am going to include the Boyer-Moore search. Now there are 3 searching algorithms. If you take a look and go into searching algorithms, you're gonna see that you have this Boyer-Moore search, you have the Boyer-Moore horse pool search, and you have the Knuth-Morris-Pratt search. Now these are, I think, these are like 3 searching algorithms. If you want to see kind of like how they work, if you, for example, go for Boyer-Moore search visualization, I've already prepared that. This is just look for Boyer-Moore string search visualization, and you're going to find that homepage. And basically what this is, you can do some text search. So if I say hello world, this is world, and then I'm looking for the string is world. If I do it like that, and I'm gonna go for searching, you can basically see that the string is kind of like always pushed backwards 1 character if it's not matching, and as soon as it kind of like finds a match, it basically the search is finished. You can see it's kind of like going backwards, and then you can see at some point it will kind of like find the occurrence of that search string in the other string, and then yeah, it kind of like gives you some informations. So quite simple, right? It starts here, they don't fit, it moves them backwards, they don't fit, they are going to fit here, and then you can see, oh, there is this one occurrence that did not fit, this doesn't fit, okay, so it moves backwards. You can kind of like skip a few slots because of how the algorithm works, and then yeah, it basically at some point finds the string occurrence. Yeah, and this is basically what we want to do now. So let's include std string, okay, and let's add some string text. So I think I also want to have it like, let's say hello world, this is a word. So what I want to look for is a word. This is what I want to find. I just want to have showing to you that it's also possible that world has like multiple occurrences and it still works. Okay, so now we have the search, and the search is equal to a world. This is what we wanted to find, and now we just need to kick this off. So Boost algorithm, and there is this Boyer-Moore search. You can either directly create a class instance. I think the class instance is for a search string. I'm not sure how around it works with the class, but what I would recommend for these searching algorithms, I would always use like just the function. Alright, so what do you need? Of course you need the text. It works with iterator, so text begin, text.end, and then we're gonna have the search.begin and the search.end. These are kind of like the iterators which I wanna iterate over for this text searching. So we have the search and we have the text, and what it returns is a iterator in the text. So auto text iterator, and the text iterator is that. So if text is not equal to text end, so this should work. Does not work. Is it a search iterator? It should. Yeah. I know. Of course, it works different. There's a first and second, and I think so. This is text.end, And so if this is not equal to text.end, so if we have something found, because basically it defines the whole string. This is like a pair of two iterators that's returned by the search algorithm. The search algorithm returns kind of like the start and the stop of the sequence found inside of text. Now what we could do now is, if we are finding something, let's maybe include IOStream quickly. IOStream, we're gonna do a quick std cout, and we're gonna say text found. And then what we can do is we can so as well add some details to it. But first let me write an else statement, std cout, and I'm gonna say text not found. And I think I have a typo there, end line, okay. Found, okay. So what we can do is we can add some stats to it. So kind of like we can set the offset. So the offset of the found text is, and how do we get the offset? Well, we do some iterator arithmetic. So we go for the text iterator, the first occurrence minus the text begins, so that we can kind of like get an offset of where that was found. So we have an offset. And we could also echo out some lengths of the search that we have done. So what is the length? Let's maybe do an std end line here. Well, it's getting a bit big now. Let's maybe, yeah, we have the offset here. Well, maybe let's do it like that. So we have the offset, and we have the lengths that we want to echo out, and the end. So the length is going to be texted second minus texted first. So it works with iterator arithmetics, as already told. Then we have some metrics, and what we can also do, we can quickly std cout a std string and build an std string on the text iterator first and the text iterator second, to kind of like get away the actual text that we were searching for. And we could actually even go in and maybe the search string, maybe we're gonna retrieve this one from cin. So maybe let's do a std cout and say text is, and then we echo our text std end line, and then we're gonna go std cout. Then maybe let's do a search. So we want to enter like a search query, and then what we're gonna do is std get line. We're just gonna get a line from std cin to the search text. Okay, so this is basically what we want to do. And then we kind of like have a bit of a searching algorithm implemented. So let's try this out, how this works. Okay, so text is hello world, this is a word. Let's search for YouTube. Text not found. So we did not find YouTube in that sequence. So let's now search for, oh, is it not activated? Let's search for a word, and it says text found, offset is 20. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So a word. So the offset works. You can also see that we extracted the string properly. And yeah, it basically can now do this special Boyer-Moore search in strings, which might be useful. You might not really want to build a full text search on that. I'm not sure if this is a good idea to completely build on top of something like that, but in the end it does work. Now in the end, this works for everything. So basically what you can do is you could even build yourself your search over, let's say, a std vector. So what we could also do is we could make this differently. Maybe let's maybe rename this one into void, and let's call this one text search. And then let's create ourselves a new int main. Int main, okay. This is now of course no longer used, but I want to keep it in for you as an example. We could maybe call the text search and add a comment so that it's not executed. But what you can also do is you can of course also search over containers, right? If you have a vector that you want to search, and you have a std vector of ints, and let's call this one sequence. So we have this std vector, and inside of that we have the sequence of 1, 0, 1, 2, 0, 1, 1, 0, 3, let's say something like that. And then you have an std vector int, and let's call this one search. So we have a search vector, and the search vector is 1, 110. This is what we are trying to find. What you can of course also do is you can say auto find equals boost algorithm boyer search, and you can search in the sequence begin, sequence end, and then you have the search begin and search end. So this is kind of like what you're doing, and this of course also works. And if I do this, I can like cdc out quickly and say search at position let's say find first minus sequence begin. So this is kind of like the position of sequence, and if I run that, let's maybe add an scd end line here. If I add that and run it, you should also get an information on where the sequence was found. So position 4, 0, 1, 2, 3, 4. And there is the sequence, which is especially useful, right? You can see that this basically works with iterators. This is only a template. The algorithm library is a big template-only library. It's header-only templates. And basically what it is doing is defining everything with iterators. It's working with iterators. You can write your own class, your own containers. At least if you have like an iterator class that is implementing something, this Boyer Moore search will be able to search your containers with that specific searching algorithm. So I've talked in quite a long time just about the search algorithm in this library. There are multiple of these. There's the source pool adaptation. I'm not too much I'm not too much into search algorithms. You would of course need to take a look on what fits for you. I think these are kind of like all the same, right? If you would go for this one, there is also a visualization of that one that works a bit different. You can search basically with this same algorithm, this Knut, Morris, Pratt string algorithm. It's somehow also having like this failure function and does things. So this is a bit more, I think, an involved algorithm. We can see that it is running quite long in comparison to how the other one runs, but it has of course also its strengths and weaknesses like every search algorithm. But I don't want to talk too much about the search algorithms. I want to go quickly over the other algorithms that are in here. I do not want to go too much maybe into the details of these, but let's maybe quickly see what algorithms are here provided. Now, these algorithms are grouped for the C++ version. So there are algorithms that start working with C++ 11, then with C++ 14 and 17, and there are also not yet documented algorithms as well as these other algorithms. Let's maybe quickly start going over a few of these. Like you have these algorithms like equal, mismatch, for each, n, transform, inclusive scan and exclusive sim, copy until, copy while, copy if until. There's like variations of copy algorithms. There's a copy if algorithm. There's a copy n algorithm. Partition point copying is sorted, is partitioned, is permutation. There's a lot of stuff going on. Like all these names are already explaining what the algorithms do. Maybe I'm gonna quickly go over one of them so that you can see how that works. Let's take a look at the all of algorithm. This is CPP what was it, CPP 11. It's inside the CXX11 folder, and then for example you could say all of. What would the all of algorithm do? Well, I can basically check if all of are smaller than 3, for example. So what I can do is I can say let's say stdc out, and I can say sequence all under 3, and then what I want to do is I want to go boost algorithm all off, and this all off algorithm is of course giving me a boolean as a result, and then I'm going to say like just like sequence begin, sequence end, and then I need to define like a predicate. I think we can just copy for that, so int I, so I'm just going to provide a lambda and I say return I smaller 3, and this should give us a proper way of telling these. So let's maybe use that one here, and then use a std end line in here. Maybe let's move this down here, and then what I want to do is I just want to duplicate that. Yeah, maybe I'm gonna, let's maybe use another C out, so this is a bit, yeah, like differentiated, and then I can do this again for the searching string, And yeah, then I have it in here. Like this is how I would do it. And if I run that one, you can see sequence all under 3 is 0 and search all under 3 is 1. So you can see in the search sequence there's everything is under 3, while in the sequence it's not. There's a 3 in here, and then it's basically yeah, doing it like that. Maybe what I personally like to do, we are not on FMT here, so what we can do is we can quickly do a true false so that we have a bit of a more meaningful output here. So let's maybe add this in here as well. And this is basically now gonna refine our output a bit and returns us true or false depending on that. So all under 3 is false, and there it is true. And now basically this is how these algorithms work, and also these like copy algorithms, like the copy if and things like that, right? Like this copy if algorithm. Where is it? There it is. Copy if. Copy is a subset of a sequence to a new sequence. If you take a look at the header, how it works, this is give like the interface. The Boost documentation is not the best. That depends on the library, but in this case it's like copy if. The name is already saying how it works. It's copying if a certain condition is met. So you kind of like have an option to copy over to a container or copy not to a container. And then it's probably going to give you the end iterator. So if we would do some copying, we could quickly do it, right? Let's maybe spend a bit of time of copying over. So let's say do an inter vector and call them numbers. And what I want to do is I want to copy all the numbers that are under 3. So let's maybe do a sequence like that. And now let's copy over. Let's do a vector int and let's call this destination. And let's say destination dot resize, and I'm gonna resize to numbers dot size, and this should give us enough space, and then we should be able to do boost algorithm. Do I not have the copy if included? No, because they're all in different headers. So copy if, and then I'm gonna go for, now of course I've accidentally removed all of header. So copy if, and then we could go for like some copy if. So copy if, we have a range, then we have a output iterator result and a predicate. So what I'm doing here is I'm gonna go in, and what I say is basically I say numbers begin, numbers end. I'm gonna copy to my destination dot begin. This is where I want to copy, and then I want to have my predicate here, and this is gonna be the number, and I'm gonna again return n smaller 3 here as a predicate function that gives us the information. So let's say maybe let's reorder this a bit so to have a bit of more time, and this is basically how the copying algorithm works. And this one should return ourselves a end iterator, and this end iterator can then be used to resize that. So destination dot resize, and I'm going to resize this to a new size, and I'm resizing that by taking our end iterator minus destination dot begin, and this should then resize our vector to the actual size that has been written, because this end iterator shall give us the last element that was written to destination. We allocate spaces for all of the elements, and then we'll resize it. That's the kind of like whole idea. Let's maybe add a breakpoint and see if this works, because I actually haven't even tried that out at all. But if we are taking a look at that, what you can see is that the numbers, there are 8 elements in there, and the destinations, there are 5 elements in there. And if I take a look at the numbers, you can see that this is like exactly what we got: 0, 2, 3, 4, 1, 2, 0, 5. So there's a lot of stuff in here, and I want to copy everything that's smaller than 3. So if we are going to our destination, you're going to see 0, 2, 1, 2, 0. So if you take a look at that, 0 is fitting, 2 is fitting, then 3 should be dropped, 4 should be dropped. Okay, it's dropped, then there shall be coming 1, 2, and 0, and then the 5 shall be cut off. And as you can see, this is exactly how it works. We have now basically copied them over to the array. You can of course also, I think, as far as I'm concerned, do this as a in-place copy. So you can copy to the same array and then resize the same array and get completely rid of the destination array. And if I do it then like this, what we should have basically is we should have the numbers. There are currently 8 elements, and if I run that, you can see it has been truncated with all of the numbers that are like bigger then that are kind of like smaller than 3. All numbers bigger equal 3 have been truncated from the array. So there are kind of like useful features in this library. Yeah, we can later on add the text as well. But yeah, that's kind of like super useful. I'm not sure. I think like something like std copy if might be already something that's in the standard. This is also something that you might need to be concerned, right? This is something that C++ has actually added to the standard, which is also something that you need to be always a bit concerned on in Boost, that Boost might contain stuff that is not maybe required. So you can see C++ standard minimum level is 3. So for CPP 3, it is basically implementing these algorithms. So even if you're on CPP 3, you can use these modern algorithms, which is kind of like the whole idea of Boost sometimes as well. Now they also have other algorithms. Other algorithms are algorithms that are kind of like implemented for like not from a standard. There are multiple ones of these. There's for example this hex algorithm. The header file contains the 3 variants, each of 2 algorithms, hex and unhex. They are inverse algorithms. That is one of under the effort of the other. Hex takes a sequence of values and turns them into hexadecimal characters, for example. Okay, so there's a lot of things that are kind of like maybe useful that you have in here. For example, hex for turning something into hexadecimal sequences. I'm not too concerned about these currently for hexadecimal and unhexadecimal, but yeah, this is kind of like the idea. You have a lot of algorithms in here that you can use also with the standard library, without a standard library, and that kind of like, yeah, a bit come together. But in the end, you have a lot of useful algorithms that can help you managing containers and making your code a bit more C++ like. Let's say it like that. That help you also with functions of these. Alright, so I think the more useful were the text search algorithm. This is also why I spent the most time explaining this one. This one is something really useful, this text searching. Also text searching into something that is not text, but this is kind of like useful, right? If you're writing a small desktop application and you quickly want to search like some records that you have, you can quickly use the searching algorithm. And I don't think even that the searching algorithm is too bad of a performance. We would of course need to properly measure it and to kind of like find a proper way of telling how good it really is. Okay, so but that's it for today's video. Thank you for watching. See you in the next one. Make sure to like and subscribe and have a nice day. Bye.